In this lesson, we are going to use the discriminant to determine the number and types of solutions to a quadratic equation. Let's see what the discriminant is. The discriminant is represented by the expression b squared minus 4ac. If you remember from the quadratic formula, the discriminant is the expression inside the quadratic formula. Okay, so the discriminant tells us the number and types of solutions that we will get after doing the quadratic formula. Sometimes you don't want to have to do the quadratic formula, you just need to know the number and the types of solutions you need. So you take the short route by doing the discriminant. Okay, so let's see what are the rules. If b squared minus 4ac, meaning if the number you receive after you simplify this expression is greater than 0, that means that you will have two real solutions. So two real solutions. Within that, well, what are the two real solutions? How are they? So if it's the number you get after simplifying this expression is a perfect square, that means you will have rational numbers, okay? If the number you get after doing this expression is not a perfect square, that means you will have irrational numbers. So your solution for the quadratic formula will be an irrational number if the number you get is not a perfect square. Let's see what else. If the number you get after simplifying this expression is less than 0, that means you will have two imaginary solutions. Two imaginary solutions. Okay? And if it equals to 0, you will have only one rational number. Only one rational number. So let's see how this works. I am given a quadratic equation and I'm asked to use the discriminant to determine the number and type of solutions I will get. So again, it's always good to write down the formula. So the expression is b squared minus 4ac. Based on the given quadratic, a is 2, b is -5, and c is 9. So let's go ahead and substitute those values. Oops. Always like to put parentheses so I know what I'm substituting in. So b is -5, a is 2, c is 9. So now I'm going to go ahead and simply simplify that expression. So -5 squared is 25 minus 4 times 2 is 8. 8 times 9 is 72. So then I have 25 minus 72. That gives me -47. Now, based on our rules, let's go back. So we have a number less, 47 is less than 0. So let's see what that means. I think this is on rule number 2. If the discriminant is less than 0, that means you will have two imaginary solutions. So our answer for here will be two imaginary solutions. Okay. Let's see another example. Now, if you notice this is not equal to 0. This equation is not equal to 0. Therefore, we have to first set it equal to 0 so it's in the correct format of a quadratic equation. We always want it to be in the standard form of a quadratic. So I'm going to go ahead and add x to both sides. Minus the 2. Now this is in standard form. So I can go ahead and do the discriminant. Again, the formula for the discriminant is b squared minus 4ac. I'm going to go ahead and substitute the values. From here, a is 3, b is 1, c is negative 2. So b is 1, a is 3, and c is negative 2. So now, 1 squared, that is just 1, minus 4 times 3 is 12, times 2 is negative 12. I mean negative 24. What am I saying, right? So then I have a negative times a negative is a positive. So that gives me 25. So let's think about this. 25 is a number greater than 0. Okay, and 25 is also a perfect square. So let's see what are my rules say about this. I think that applies to rule number 1. If the discriminant is greater than 0, greater, therefore you will have 2 real solutions. Well, let's see what are our real solutions. If it's a perfect square, that means you will have rational solutions. So 25, it is a perfect square. Therefore, we will have 2 rational solutions. Okay. Let's see. Do we have more example? Yes, we have one more example. And again, we need to make sure our equation is in standard form. And if you notice, this is not in standard form, so I need to rewrite it and then solve for the variable and set it equal to 0. Go ahead and distribute. So negative 2 times 2x, that gives me negative 4x squared. Negative 2x times negative 3, that gives me positive 6x, equals negative 1. I'm going to go ahead and add the 1. Okay. Now, if you want your coefficient to be completely in standard form, which means the coefficient of the first term is positive, you can go ahead and divide by negative 1. But in this case, that will not change our answer. So we're going to leave it to that. Okay, so now I go back, and again, the more I write my formula, the more I will know it. This is the expression to use to determine the discriminant. So B is 6, A is negative 4, C is 1. 6 squared is 36. So then I have 4 times negative 4 is negative 16 times 1 is negative 16. Then I have 36 plus 16, and that gives me 52. Isn't 52 a number greater than 0? Yes, it is. Is it a perfect square? It is not. So let's see what our rules say. I think that applies to rule number 1 as well. So it is greater than 0, but it is not a perfect square. Not a perfect square. Therefore, we will have 2 irrational solutions. So 2 irrational numbers. Let's write that down. Okay. And I think that's it for this examples for the discriminant. So in this lesson, you learn how to use the discriminant to find and determine the number and types of solutions you will have for a quadratic equation. And again, the expression to determine the discriminant is this. And this comes from the inside of the quadratic formula.